Armenia has recently enhanced its defense capabilities by acquiring the Zen anti-drone system ZADS from India, a significant move in the context of its ongoing conflict with Azerbaijan. This procurement is valued at approximately $41.5 million. And in today's video, we will delve into the specifics of the Zen anti-drone system, a standout example of India's growing expertise in defense technology. So, let's start. The Zen anti-drone system stands for ZADS, made by Zen Technologies, is a sophisticated counter-unmanned aerial system designed to protect against drone attacks. ZADS uses multiple sensors and layers to find, classify, and track drones. The system scans many frequencies that drones usually use. When it finds a drone's frequency, it focuses on that signal and figures out where the drone is coming from and deal with it accordingly. The history of drones in India dates back to the late 1990s when the Indian Army first acquired unmanned aerial vehicles from Israel. India's first significant use of military drones was during the 1999 Kargil War with Pakistan. Since then, India has continued to enhance its drone capabilities, with notable procurements including 10 Harrops in 2009 and 54 Harrop attack drones in 2019 from Israel Aerospace Industries. Parallel to these acquisitions, the Defense Research and Development Organization (DRDO) of India has been actively developing domestic UAV and UAS programs which include drones like Lakshya, used for discrete aerial reconnaissance, Nishant, designed for intelligence gathering, Aura, a stealth drone capable of releasing missiles and precision-guided munitions. And finally, the development of ZADS marks a significant leap in India's trajectory of drone and counter-drone technology. If we talk about features and specifications of the ZADS, first of all, the RF-based drone detector RFDD forms a core component of ZADS. It operates by detecting drones through radio frequency communication between the drone and its ground control center. Upon identifying a frequency of interest, the RFDD locks onto and monitors the signal, determining the direction of both the drone and its GCC with an array of receive antennas. In addition to RFDD, ZADS incorporates video-based drone identification and tracking. Equipped with day and night camera sensors mounted on an automatic servo-based positioning system, it can capture and track video footage of drones up to a range of 3 kilometers. For the detection of autonomous drones, which operate without a link between the drone and the operator, ZADS utilizes an X-band 3D radar. This radar system is adept at detecting such drones, providing precise data about their coordinates, including both azimuth and elevation. Next, let's talk about the DFCC in the ZADS system. It's a key part where it combines data from RFDD, VDIT, and radar. This center uses special algorithms to detect and classify threats using both radio frequency and visual data. The DFCC has a display system that shows different things like spectrum and waterfall screens. It not only shows what it detects but also uses a map with threat zones. This helps in keeping an eye on things and making quick decisions. ZADS primarily operates as a soft kill system, which means detecting and jamming drone radio frequency emissions from distances ranging between 10 meters to 10 kilometers. In the soft kill system, ZADS use its drone RF jammer, which can break the connection between the drone and its controller by blocking various signal bands. It uses the frequencies found by the RF-based drone detector to create and send out jamming signals. Except that ZADS offers hard kill options for direct neutralization of drones. This includes kinetic-based neutralization with a gun that auto-aligns to the target and fires bullets, physically destroying the target. Another option is a net-based drone capture mechanism, ideal for small rogue drones carrying explosives. This system employs a dedicated drone equipped with a hanging net to capture and safely land rogue drones. The hard kill part of ZADS uses upgraded L-70 guns to destroy targets. The L-70 is an old World War II anti-aircraft gun. It's been updated with ZADS to fight drones better. These guns were first made by the Swedish company Bofors AB and then in India by the Ordnance Factory Board. The ZADS L-70 system's effectiveness against swarm drones is particularly notable, with the capability to launch predictive fire at the future positions of the swarm. As per publicly available data, the IAF received 10 units of ZADS as part of a contract for 23 indigenously developed anti-drone systems, signed on September 4, 2021. This contract also allocated 7 units to the Army and 6 to the Navy. Furthermore, the IAF ordered an additional 25 ZADS units for about $20 million, with 2 units delivered by July 2022 and the remaining 23 were scheduled for delivery by October 2022. In parallel, the Indian Army has been actively enhancing its anti-drone capabilities by ordering 20 units of ZADS, with a total contract value of approximately $27.3 million. The delivery of these systems to the Army is expected to commence in March 2024. All over the world, there are many high-tech anti-drone systems like India's ZADS. For example, the Coyote system from the USA, made by Raytheon, is known for working both on the ground and in the air. Israel's Drone Dome, made by Rafael Advanced Defense Systems, has radar, sensors, and jamming tools. The Anti-UAV Defense System, a project from the UK and USA, can stop drones up to 10 kilometers away. France's Thales Eagle Shield uses different methods like radar, cameras, and jammers for both military and civilian uses. Also, Israel's Skylock anti-drone system combines radar, RF jamming, and other technologies to find, confirm, and stop drones. India is becoming an important player in making anti-drone technology. It might not be leading like the USA or Israel, but its work, especially with ZADS, shows a big step in making its own defense tech. In conclusion, India's anti-drone system ZADS represents a significant advancement in the country's defense capabilities. Designed to efficiently detect, track, and neutralize unmanned aerial threats. This system is a testament to India's commitment to developing indigenous defense technologies and reducing reliance on foreign equipment. As threats from unmanned aerial vehicles become increasingly sophisticated, the deployment of systems like ZADS underscores India's proactive approach in adapting to modern warfare challenges. Thank you for joining us in exploring the Zen anti-drone system. If you found this video insightful, do hit the like button, share, and subscribe for more military tech insights. Until the next video, stay curious and keep exploring.